Hello everyone, welcome to Homework Hell. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivatives of these three functions. So let's start with the first one. So y equals x squared over tan pi x. Now this expression is in the form of a fraction. There is this x squared, a polynomial function in the numerator, and tan function in the denominator. So we can use quotient rule to find the derivative of this function. So as per the quotient rule, so we start with the derivative of the numerator, and as per the power rule, the derivative of x squared is 2x times the denominator minus the numerator expression times the derivative of the denominator, and the derivative of tan function is secant squared. Now for this tan function, we have to use chain rule to find the derivative because the outer function is tan and the inner function is pi x. So the derivative of the outer function tan is secant squared, and for the inner function pi x, the derivative is pi times 1. So pi is the coefficient of the term and it's a constant, so it stays as it is, and the derivative of x is 1 over the square of the denominator. Now we can simplify the expression in the numerator. So in the first part, we just get 2x tan pi x. And in the second part, so pi times 1 is pi, and we can multiply pi by x squared at the front. And in the denominator, we get tan squared pi x. Now we can simplify the numerator by factoring out an x. So we're doing common factoring. So this should be the final answer for the derivative of the first y equation. Now we can analyze the second equation, y equals tan x squared minus tan squared x. Now in this equation, in the first term, the square is on the x, not on the tan. And in the second term, the square is on the tan and not the x. Now in order to make it easy to find the derivative, we can modify this equation by putting the square on tan x in the second term. Now we can find the derivative of this function. So in the first term, we have to use chain rule because this first term has an outer function tan and the inner function is x squared. So as per the chain rule, we'll start with the derivative of the outer function, and the derivative of tan is secant squared times the derivative of the inner function. and the inner function is x squared, and as per the power rule, the derivative of x squared is 2x minus. Now for the second term, we'll have to use chain rule again because the outer function is the square function and the inner function is tan x. So we'll start with the derivative of the outer function. So we'll use power rule. We'll move the exponent 2 to the front and subtract 1 from 2 times the derivative of the inner function, which is tan x, and the derivative of tan is secant squared. Now we can simplify this expression. So in the first part, so we can move the 2x to the front of the secant term. And in the second part, so in the exponent, 2 minus 1 is just 1, and we don't write 1 as an exponent, so we just get. So this should be the final answer for the derivative of the second y equation. Now we can find the derivative of the third y equation. Now in the third y equation, there are two trig ratios, sine and tan, and they are being multiplied. So here we can use product rule to find the derivative, and 3 is the coefficient of the term, so we can keep the 3 outside the parentheses. So we can start at the bottom. So dy over dx, so the 3 can be kept outside the parentheses. And now we can use the product rule. So as per the product rule, we'll start with the derivative of the first function sine, and the derivative of sine is cos times. Now since this sine 5x is a composite function, the outer function is sine and the inner function is 5x, we'll have to use chain rule. So we found the derivative of the outer function, which is cos 5x, times the derivative of the inner function 5x, and the derivative of 5x is 5 times 1 times the second function, which is tan 5x, plus the now the first function times the derivative of the second function. So we again have to use chain rule because there's this outer function tan and the inner function is 5x, and the derivative of tan function is secant squared, times the derivative of the inner function, and the derivative of 5x is 5 times 1. Now we can simplify this expression. So we'll keep the 3 outside the parentheses and we can simplify the term. So in the first part, 5 times 1 is 5. So we can move the 5 to the left side of the cos term. And in the second part, again we can multiply 5 by 1, which is 5, and we can move the 5 to the front of the sine term. Now we can factor out 5 from both terms in the parentheses. So we are left with Now we can multiply the 3 and 5 and we get 15. So this should be the final answer for the derivative of the third y equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.